Hey guys, welcome back to another logical reasoning tutorial. In this tutorial, we're going to cover must be true question, okay? However, there's going to be a little caveat here. These must be true questions are going to be the must be true except questions, okay? So what is a must be true except question? Well, a must be true except questions are going to be basically like your garden variety must be true, except in this case, it's going to be a type of question where anything that you can infer will be the wrong answer, and anything that you cannot infer will be the right answer. So again, let me repeat that. Anything that you can infer from the stimulus will be the wrong answer, and anything that you cannot infer will be the right answer, okay? So let's get started. With this question, we can find it on LSAT Preptest 13, Logical Reasoning, Section 2, number 14. And this question is going to be a formal logic question. It's going to involve two quantifiers. We're going to have all statements, and then we're going to have our sum statements. So let me do a quick review on what a sum statement is on the LSAT. A sum statement on the LSAT is basically a statement that ranges from 1 all the way up to 100. Okay, so that's the scope, that's the range for a sum statement. So these are some of the characteristics you want to know for sum statements. Okay, number one, sum statements are reversible. So in logic, we call that commutative. So basically, if I tell you some A's are B's, well, that's functionally the same thing as saying some B's are A's, okay? They mean exactly the same thing. So some statements are reversible. That's number one. Number two, some statements have no contrapositive, because if they're reversible, how could you have a contrapositive, right? So that's why some statements have no contrapositive. Just keep that in mind, okay? And remember the scope of a sum statement. It can range from 1 all the way up to 100, okay? And then remember, since it has no contrapositive, some and some are not the same thing. So just keep that in mind, okay? So let's get started. Now, I'm going to show you in this tutorial how to put some and all statements together and draw some sort of conclusions from it, okay? So let's see what we have here. It says, some of the world's most beautiful cats are Persian cats. However, it must be acknowledged that all Persian cats are pompous, and pompous cats are invariably irritating. So now, how do we know we're dealing with a must be true except? Well, it's simple. They tell you. They have to tell you this, okay? So if the statements above are true, which one of the following must also be true on the basis of them? All right, so let's get started. Let's see how we're going to combine these quantifiers. So here's basically going to be the hack. I'm going to show you how to take the sentences take them apart, and then we're going to combine them and draw some sort of conclusion from them, okay? So let's get started. Okay, so with sum statements. So in this stimulus, we start off with a sum statement right off the bat. Okay, so they tell you some of the world's most beautiful cats are Persian cats. Basically the heuristic on how to deal with sum statement, guys. Okay, this is the hack. Okay, what you want to do is you want to draw a circle, and then you want to put beautiful cat into the circle here, so we can abbreviate that as BC, and then Persian cats, we can abbreviate that as PC. That's all you need to do. Once they're in the sum circle, we can say it in any order we like. We can say Persian cats are beautiful cats, or beautiful cats are Persian cat. They mean exactly the same thing. That's functionally the same thing as me telling you if it's some A's are B's, then some B's are A's. It's literally the same thing. So it doesn't really matter. Let's go on to premise 2. Okay, so now premise 2 tells you, however, it must be acknowledged that all Persian cats are pompous, and pompous cats are invariably irritating. Okay, so now we basically have two sentences that are joined together by a conjunction here. This is basically an and statement. An and statement in logic is called a conjunction. I'm going to do a whole tutorial on that and show you how to deal with an and statement, okay? Or in which case, in logic we call it a conjunction. But right now, for this lesson, it's not necessary to know that. Okay, all we need to know is basically how to translate all statements. Okay, because basically it says, however, it must be acknowledged that all, see that? All Persian cats are pompous, and pompous cats are invariably irritating. Up to this point, you should know how to translate a garden variety if-then statement. Okay, so this is basically an if-then statement. All right, so premise 2, all Persian cats are pompous. So we can say PC, arrow, pomp. Okay, and of course, you can also draw the contrapositive, which is not pomp, not PC. Just flip and negate. Now premise 3, all pompous cats are invariably irritating. So that's what we have here. Pomp arrow, irritating. So of course now, up to this point, you should know that we can hook these two premises together. So we can basically say this. This is what we can basically say. We can all hook it together in a transitive form and say PC, arrow, pump, arrow, IR, irritating. We can basically draw two distinct conclusions from this, from just the all statement alone. We can say PC all the way to IR, or we could basically infer the contrapositive, which is the same thing. Okay. Remember, the contrapositive is like the opposite side of a coin. Okay, it's like heads and tail. They mean they have the same value. They have the same value. They mean functionally the same thing. So just keep that in mind. With the contrapositive, we have not irritating, not pompous, and not a Persian cat. Okay, so now, what do we do up to this point? Well, it's very simple. I'll show you the heuristic. This is going to be basically the strategy on how to combine sum statement. So what you want to do now is you want to look to see if you have any triggers. Now, what do I mean by triggers? Well, a trigger means that if you have a variable, let's say BC, or an arrow that points to something else. That's basically what a trigger means, okay? At least that's what I'm referring to when I'm saying, does it trigger something else? Okay, so let's take a look. BC, does BC trigger anything? No, it does not, right? Does PC trigger anything? Yes, it does. It triggers two other variables. It triggers pompous and invariably irritating. So let's see what we have here. So now let's put it all together and let's see what we have. Okay, so now we can basically say in the sum circle, we can say beautiful cat, Persian cats, pompous, and irritating. Now here's the cool part, because now it's in a circle, sum circle, and remember, sum doesn't have any contrapositive, so now you can say in any direction, any order you like. So you can say BC, PC, pompous, irritating, or you can go the opposite direction. You can go pompous, irritating, beautiful cat, Persian cats, or you can say pompous, irritating, beautiful cat. It doesn't really matter, okay? Once it's in that circle, it basically takes on a whole new characteristic, and it takes on the whole characteristic of sum, and that's basically what it means, okay? So now you can say sum about all these guys. So these are all the stuff that you can infer about this logical reasoning stimulus, okay? So let's see what we can say now. All right. So let's go back to the question and let's find the right answer. All right, so let's see. So for A, it says some of the world's most beautiful cats are irritating. Let's go back to this circle and let's see what we have here. Some of the world's most beautiful cats are irritating. Yes, it's in the circle here. Beautiful cats, irritating. So it's here, okay? So we can infer that, so that's why that's wrong. Okay, so let's see. Some irritating cats are among the world's most beautiful cat. Well, that's also in the circle, guys. So that's why that's wrong, because we have irritating and beautiful cats. They're both in the circle, okay? So now let's take a look at C. Any cat that is not irritating is not a Persian cat. You notice what they did here? A, B, they both start with some, and now all of a sudden we jump to all. Let's see what we can say about all, okay? So with an all statement. Okay, so all, well, it looks like we can say that if they're not irritating, they're not Persian cats. So that looks like we can also infer that. Okay, so that's not going to be the right answer. So now, some of the pompous cats are among the world's most beautiful cats. Yes, we can also infer that, because that's also in the circle. If it's a pompous cat and it's also the world's most beautiful cat, that's also in the circle. So A, B, C, and D are all stuff that we can infer. Okay, just look back at your circle and you'll see that's all in the circle. C is basically just the contrapositive, the all statement. Okay, so we can also infer that. That's why that's also wrong. Okay, let's see E. Some irritating and beautiful cats are not Persian cats. So look at what we have here, not Persian cats. So let's take a look at the circle again, okay? We don't know anything about if they're not Persian cats. We only know if they're Persian cats. So this is something that we cannot infer. So that's why this is the credited answer, okay? So that's why E, some irritating and beautiful cats are not Persian cats. That's why this is the credited answer, and this is why this is the right answer, okay? Okay, so Now you guys basically understand how to combine sum and all in formal logic, and I'll see you guys next time. QED, that means we basically prove this whole entire statement. QED says that which must be proved, and that's what we did. All right, guys. So don't forget to like, share, and comment, and I'll see you guys next time. Thank you.